Okay, welcome everyone to the Fur demo. And things begin with Fur when creating a private space. So you can see here we have our classic runtime options and our Heroku's next generation runtime known as Fur. So this is essentially how you'd get started, creating a space, picking the name as usual, the space owner and usual information. So I've gone ahead and already created a space for us for this demonstration. So the next thing we need is an app, and we're going to deploy that app using our Visual Studio extension for Heroku, which does give us the opportunity to pick the space that we're going to deploy this to. So we're going to choose our app called Node.js Fur, and we're going to pick the app owner, which is DevRel. In this case, Development Relations has a space set up called DevRel Fur East, and we're going to ask it to deploy that. So while that's deploying, let's take a look at some of the other differences. So this is the classic platform generation. You can see here when you're using dynos, you can get the option of standard dynos or performance dynos, and there's a myriad of options there. What we found, though, is customers want more flexibility, more options with that. So you'll find when you look at the equivalent screen in Fur, there's quite a number of other options. It's a rather more interactive experience where you pick your CPU and then available RAM configurations below. So lots more choice to allow customers to really understand what their requirements are and tune their particular choices to that, and of course their budget accordingly. So next up, another difference you'll notice inside Fur applications is the use of cloud-native build packs. You might remember this used to say build packs before. Well, we've now got cloud-native build packs, so this is a very important aspect of our strategy to align with Cloud Native Foundation and their projects and making whole use of those technologies, not just cloud native, but also OTels we'll talk about later, really easy to use. So this acknowledges the use of cloud native build packs, some of which are provided by Heroku, others can be provided by third parties in the future. So here is our standard metrics page, and this is available for Fur applications. The usual information is here. However, some metric information isn't yet available right now, so do keep that in mind. OTel is a technology that we've embraced for Fur, and it is really the successor of how you use Heroku to get information out about what's happening with your application in production and your own instrumentation that you've added to your application in your code itself. And as we've spoken about, Cloud Native Foundation is a container for a number of technologies, and this includes OpenTelemetry. This is their project website, and we can go and take a deeper look at what that looks like in terms of learning more about OTel. So do feel free to navigate the OTel pages and understand more about this technology. It is widely used across the industry, and having a good basic understanding of that is really important. As is, in fact, understanding tools that you can use with OTel. So Grafana is one of the tools we'll use in this demonstration, but there are, of course, many because it's an open standard, so there's a nice ecosystem of tools that use that standard. So do be familiar with Grafana by all means, but be aware that there are multiple other tools customers might already have and prefer to use with Heroku. We also have some amazing documentation that is available for working with Heroku and telemetry drains. So that's a new kind of phraseology. We're not using log drains for Fur, we're using telemetry drains. And of course, there's a new set of CLI commands that go along with it. In principle, it's very similar to log drains. You do need to make sure you have an endpoint in which to send the telemetry to, and there's some authentication required to set all of that up. So I've gone ahead and set myself up in Grafana Labs as a user. There is a free version of it for a certain time period, and it gives you all sorts of credentials and environment variables and things that you need. Okay, so let's go and take a look at our Visual Studio IDE here, and we can see that our deployment has finished. There's a nice green icon representing the app is up and running. We've also got a nice confirmation here, by the way, that we're using cloud native build packs in here, and we can go ahead and do the app menu and take a look at the information for this app that actually just runs the Heroku apps CLI command in the console here. Nice easy way of running that. And we can get confirmation, yep, we're running the CNB stack, and that's the space that we expected it to be running on. So let's go ahead now and configure OpenTelemetry, and I've already captured all of the environment variables. They're set up for me to use, and all that remains is really to run the CLI command telemetry add to configure Grafana with this Heroku application. So I'm actually going to use the Visual Studio add-on. You'll notice here it's determined that there's a CLI command that's relevant to Heroku and offered to run it in this shell script. So I'm just going to click run, and it'll duly run that command down there in the terminal window. And we'll very shortly get confirmation that our log drain has been added. Excellent. Okay, so the next thing we're going to do is just grab our URL for our deployed application so that we can go and simulate some load on that application and see the log telemetry appearing in Grafana. So let's go and copy that URL, and we'll scoot over here and update the URL on the right here. That represents our deployed application, and already we'll start to see, as we start hitting some refreshes here on the left-hand side, you can see that Grafana is starting to show output from the router, and you can see our Node.js application, which is the one that I've just deployed, is starting to trigger records that are coming through into Grafana. Grafana also provides a number of other information like metrics in terms of CPU time and usage, and so on and so forth. I'm going to keep this demo quick and just really leave it at that, but hopefully you've got a great idea of how now you can configure very easily OTel with Heroku applications and very popular OTel client libraries and tools. Speaking of client libraries, I just want to close out with pointing out that because it's an industry standard, developers can use this from within their own application code, because you might also want to augment the telemetry that we're outputting from the Heroku platform with your own telemetry from your application logic. Maybe you're running some worker processes, or you want to add extra detail that's not output from Heroku. Well, you can do that very easily, and NPM here has an OpenTelemetry SDK for Node.js. There's one for Spring Boot, Java, and .NET. The list continues, basically. There are SDKs practically for every known popular language that you might want to use, and certainly available on Heroku. So thank you very much. Hope you've enjoyed this demo.